Encana USA currently operates more than 2,500 producing wells in the Piceance Basin of western Colorado. This is one of our most important gas-producing regions in North America, generating about 400 million cubic feet of gas per day. One of the first steps in developing natural gas is drilling the well. Here is a rig that is typically used to drill to the deep gas formations found in the Piceance Basin. These rigs are capable of drilling to depths of 10,000 feet or about 2 miles. More than 95% of Encana's wells are drilled directionally, with an average of 4 to 8 wells per pad. We currently contract 20 drilling rigs in the Piceance Basin. The red equipment beneath the rig floor is called the blowout preventer stack. This safety equipment is used to control the formation pressures and drilling fluids circulating in the borehole.
Okay, as we're drilling the well, and if we get into gas or high water flow, what we can do with this is we can shut down our drilling operation. And these are valves in here. The round one's called an annular, and it's like a large rubber donut. And hydraulically comes up and squeezes off, and it'll squeeze off and close off a pencil. Down in here, it's called a double gate shaper. The top part of that is like a valve. It'll close right around the drill pipe. And the other part is when you're out of the hole, it's called a blind rim. And right here, this silver looking pipe coming out here, hose, we can divert it around in through a choke manifold that will separate our gas and our mud, allow us to treat our mud so we can go back to drilling.
The first hole to be drilled, known as the surface hole, is commonly drilled with a 12 1/4 inch bit. On the way down, we drill through the shallow Wasatch sands where many of the domestic water wells are located. Most domestic water wells in the Piceance Basin are less than 300 feet deep. The depth of the surface hole varies depending on the total well depth, but is commonly between 500 and 1,200 feet in depth. What you don't see is the drilling mud that circulates through the drill string and bit.
Basically, our mud system is the heartbeat of the operation. As it goes down through the drill pipe, as your bit's down there cutting your hole, returning the cuttings back, but also as you're drilling a hole, it's putting a wall cake coating on it to help keep moisture fluid from soaking back into your formation. Helps us keep it from caving in on us. Our mud returns back out of the hole through them blowout preventers and goes out through that rotating head into this line right here. It's called a flow line. It diverts our mud across these shakers, and these shakers, they put the mud across, and through vibration it allows the clean mud to fall through, and the cuttings that we're bringing up, it shakes them off. And here's the final product, and that's what we're chewing up as we're drilling it.
Now this is called a centralizer that they're putting on there. Its purpose is to center the pipe.
After the 12-inch hole is drilled, we remove the drill string and run the 8 5/8 inch surface casing down into the hole. The brown object on the outside of the casing is a centralizer. It centers the casing in the borehole prior to the cementing process. The cement is pumped down the entire length of the casing out through the bottom, so the cement circulates back up around the outside of the casing all the way to the surface. This seals the space between the casing string and the borehole. The surface casing, now cemented in place, provides a barrier to shallow groundwater. Next, a 7 7/8 inch bit drills all the way to the total depth, or about 6,400 feet in this well. After drilling through the Wasatch Formation, we reach the Williams Fork Formation, which consists of 2,000 to 2,500 feet of sand, shales, and siltstones. A polycrystalline diamond compact bit is used to cut through the very hard and abrasive rocks. We finally reach total depth in the Rollins sandstone. Now we pull the drill string and drill bit from the hole. Electrical and neutron logs are run on a wire line from the bottom of the well up to a depth above potential gas-producing zones. These logging tools are very sensitive instruments that measure various properties of the rocks and help Encana engineers and geologists determine where the hydrocarbons are located in the wellbore. After logging the well, either 4.5 or 5.5 inch production casing is run into the 7 7/8 inch hole. One of the final steps in drilling the well is to cement the production casing into place, the same way we did before with the surface casing.
We're going to cement this production casing. Now we're doing some things a little bit different tonight than we've done in the past. Due to the fact we had some lost circulation on this well, we're pumping an extra treatment on this well. So 5 barrels a minute mix, 5 barrels a minute displace, until we get to about 15 barrels from displacement. If we need it, we'll pull it back out of the tank, put it back in the pit.
Okay.
Everything is shut. You're going to pressure test as soon as they get their line hammered up, right? What you're looking at is the cementing manifold on the casing. Okay, we have started pumping. Stay off of the lines. Now, did you open all my hopper valves and everything back here?
Yeah, everything's opened up.
We're pumping.
We're taking another load of.
Go ahead and take another load.
Yeah, we got one load off already.
All right, you're blowing it into a tank now?
Blowing this right here.
All right, go ahead and start taking some more. What we have up here is a state-of-the-art cementer, cementing truck, cementing unit. This is computerized display. It's a touchpad, touch screen. Real easy for him to watch everything that's going on out here. This truck, nice setup.
The cement is pumped down through the inside of the casing, up around the outside between the bore hole and casing, until the cement is above potential gas-bearing zones as determined from the logging tools. Last, we run an acoustical tool called a cement bond log on wire line in the same manner as the prior logging tools. This device measures the quality of the cement bond between the bore hole and the casing, and also helps determine how far up the hole the cement is displaced. This well is now drilled, cemented, and logged. About 1 to 3 weeks after the drilling rig leaves, well completion activities begin.
We got the sand haulers coming in, okay? So whenever possible, have your guys help them get in there, back up. We don't run into anything.
Well completion includes perforating the well, hydraulic fracturing of the gas-producing formation, commonly referred to as fracking, and finally, bringing the well on production. We'll start with the tools needed to perforate the casing.
Right here, that is one gun. And we'll run anywhere from 5 to 7 of those guns at one time, so we can place a number of holes precisely where we want to put them. Yeah, there's a jet charge inside of this. This is called a steel hollow carrier. The jet charges are protected by this so they don't get hurt going in the hole. There's a detonator in every switch right here. This is a switch area. So when we shoot this, the primer core is detonated, and then that'll ignite the jet charges. The force and the heat will burn a hole through the casing and go out in the formation. Now we got the plug and the guns. We'll pick all that up together, and it'll go up in the lubricator. What the lubricator does is allow us to run this in the hole under pressure.
The perforating guns are lowered into the well to the desired depth. Once detonated, these jet charges penetrate the steel casing and cement sheath out a few inches into the dense, tight sand formation. This process is the first step in creating a pathway for the gas to flow into the well. Water and sand are essential to the fracking process. Approximately 2 million gallons of water and 1 million pounds of sand are required to frack each well. Encana uses tanks and pits to house enough water on location to complete the fracking process. Where infrastructure is in place, Encana pipes water to the frack location.
We recycle 100% of our water, which is a good thing. It's just we have to move it from a lot of places. So that's what makes pits even better.
Many factors affect whether a pit or tanks are used, including resident concerns and size of location. A pit will hold considerably more water than tanks, resulting in less truck traffic overall. We line all our pits with an industrial-rated plastic liner to prevent water from seeping into the ground.
This is the heart and soul of the fracking side, really.
A variety of equipment is used in the fracking process. Pump trucks, sand containers, a blender truck to mix sand and water, chemical storage, a fuel truck, and the computerized command center. The chemical additives used in fracking are an acid solution pretreatment to clean out the perforations, a friction reducer to improve flow, and a surfactant or soapy agent to help bring the water back out. These additives are used at very low concentrations. A maze of piping and hoses are required to connect all this equipment to the wellhead.
So what you see now on the wellhead, the yellow item there, that's our frac valve. That's kind of our main isolation tool. On top of that is what they call the frac head. And you can see the silver piping, if you will, tied on the sides of the frac head. That's what we pump the water and sand through to frac the well.
A 15-person crew operates and continuously monitors all the equipment.
This is the command center, so we're monitoring pretty much everything the frac job does. The main components, obviously, are pressure, and then rate, and then the chemicals we use, and sand. So we tested the lines, and we're opening the well right now.
The Williams Fork Formation is fracked by pumping water and sand together in a slurry under high pressure to break open the tight gas-bearing sands and create improved flow paths for the gas. The quantity of water and sand pumped depends on the size of the interval being fracked. The water under high pressure cracks the rock and creates the flow paths, or fractures. The sand settles into the fractures, providing a path for the gas to follow, and allows the fractures to remain open after the pressure is released.
Basically, you made a crack in the rock, and then you're packing it full of sand. You're basically forcing sand to hold that fracture open so that the gas has a better path to get out of the well.
Next, we set a temporary bridge plug directly above the zone just fracked.
The reason we call this a frac plug is that we got a hole that goes all the way through this, so everything below this plug will flow through it. And we have a ball on top that sits up here where it can't flow back down.
This procedure of fracking and setting bridge plugs is repeated from 5 to 7 times per well.
Flowing this well, it's coming out right here. It's going into this iron, and it goes into our pressure vessel over here, where that separates the water and the sand and the gas.
Using this pressure vessel eliminates the need for flaring, and it allows us to move gas into the pipeline system and on to market, even as we're fracking the next well. After the well into production are completed with a smaller truck-mounted workover rig later on.
What we're doing today is we're picking up the production tubing. We've got a tricone bit on the end that we use for drilling up. They set one in between.
Tubing is run into the surface system. This vital resource through the gathering and processing steps required to sell the product to markets that make it available to our homes and businesses.